Hello and welcome to STAT 441 at VCU. In this lecture, we will learn about how to conduct a hypothesis test for population proportions. So when we are conducting the test for the proportion, we will pick a large sample from the population, and the proportion of successes is assumed to be approximately normal. With that, we will use the general formulas that we use for large sample Z tests, and to test to see if we have a sufficiently large sample. Just like confidence intervals, we can check to see if n times q hat and n times p hat are both greater than equal to 4. So this will be our assumption. Now, just like for the mean, for the proportion, we can conduct a one-tailed or a two-tailed test. The parameter will be denoted by p, and p0 will be the value that we are comparing it with. It could be a greater than test or less than test, which will be a one-tailed test, or it could be a two-tailed test, which means it's a not equal test. The test statistic will be p hat, which is the sample proportion. So you count the number of successes in the sample and divide by the sample size. P naught is this number from the hypothesis, and then the denominator is P naught Q naught divided by N, which is the sample size. Okay, so we'll use the p-value method again for this one. And again, it's very similar to the one that we saw for the sample mean for when we have a large sample. Probability of z greater than z calculated, that will be the p-value for a greater than test. For a less than test, probability of z less than the z calculated. And for a two-sided test, 2 times probability of z greater than absolute value of z calculated. The decision rule and the way we write the conclusion is the same that we have used for the other tests. Okay, so with this information, we can try an example here. Controversy surrounds the use of weathering steel in the construction of highway bridges. Critics have recently cited serious corrosive problems with weathering steel and currently urging states to prohibit its use in bridge construction. On the other hand, the steel corporations claim that these charges are exaggerated and report that 95% of all weathering steel bridges in operation show good performance with no major corrosive damage. Okay, so to test this claim, a team of engineers and steel industry experts evaluated 60 randomly selected weathering steel bridges and found 54 of them showing good performance. Is there evidence at alpha of 0.05 that the true proportion of weathering steel highway bridges that show good performance is less than 0.95? So 0.95 is the proportion we want to compare it with. And so to see if the bridges are deteriorating, we would like to test P equal 0.5 versus P less than 0.5. So if the proportion is less than 0.95, it's a problem. So we will test to see that. Okay, where P will be the true proportion of all weathering steel highway bridges that show good performance. So let's first calculate P hat, which is the sample proportion. So 54 out of 60 bridges showed good performance, that is 0.90. Now the test statistic will be P hat minus P0. So P hat is 0.9, P0 is 0.95, and then the denominator will be 0.95 times 0.05 divided by 60, which gives us negative 1.78 as our test statistic. Okay, so if we check the assumptions, we have 54 successes and then 6 failures. Both are more than 4, so we're good to go here. P-value will be probability of z less than negative 1.78. That's our test statistic value. So from the table for 1.78, we can read the value as 0.4625, and then 0.5 minus 0.465 will be for less than negative 1.78. 0.0375 is that p-value. At 0.05, we will reject the null hypothesis. That means that there is sufficient evidence to support that the proportion of bridges that show good performance is actually less than 0.95. Okay, so that's the test for proportions. Okay, so here again, a quick look at the probability calculation, z less than negative 1.78. So the way we will do this is, because of symmetry, if we look up 1.78, we will have this area. Okay, so what we are doing is we are looking up 1.78 from the table, 1.78, okay, and then subtract that from 0.5 to get our p value. Okay, so a similar test can be done for comparing two population proportions. So we want to conduct a hypothesis test where the null hypothesis will be of the form P1 minus P2 equal to a D0 value, the difference value. Now, in this case, we will look at two specific cases. First case will be when D0 is 0. So we're just comparing the difference to 0 versus when D0 is not equal to 0. So we have a specific value to compare with, like P1 minus P2 is greater than 0.2. So difference of 20%. Versus P1 minus P2 equals 0. That means that the difference is just compared with 0. So for these cases, we have slightly different test statistic, and the rest of the test, the p-value, how to find the decision and conclusion would still stay the same. Okay, so let's first start with the special case when the D0 value is 0. That is when we are testing H0, P1 minus P2 equals 0, or equivalent to this would mean P1 equals P2. Okay, so the best estimate that we can find for P1 and P2 would be found by dividing the total number of successes in the combined sample by the total number of observations in the two samples. That's where we will find the value of P hat in this case by adding the two successes for both samples together, dividing by the two sample size put together. Okay, so because of this, the estimate that we have for the standard deviation for the sampling distribution of P1 hat minus P2 hat will be, instead of P1 Q1 divided by N1 and P2 Q2 divided by N2, we will put it together, kind of like the idea of pool variance. So we have square root of P hat Q hat times 1 over N1 plus 1 over N2. So this is what we will do when we have D0 value equal to 0. Okay, so here is our summary for the test. P1 minus P2 equal D0. Then we have HA could be a greater than, less than, or not equal sign. The test statistic value will be Z equal P1 hat minus P2 hat. That's the two sample proportions, minus D0, and then sigma of P1 hat minus P2 hat. P-value calculation depends on the sign of the test. So greater than, probability of Z greater than Z calculated, less than would be probability of Z less than Z calculated, and 2 times probability of Z greater than absolute value of Z calculated for a double-sided test or a two-tailed test. Okay, so here is the sigma P1 hat minus P2 hat for the two cases. When the D0 value is not 0, we will use square root of P1 hat Q1 hat divided by N1 plus P2 hat Q2 hat divided by N2. But when the D0 value is 0, we will put this together. P hat will be the sum of two successes divided by the two sample sizes. And our standard deviation that we will use will be square root of P hat Q hat times 1 over N1 plus 1 over N2. The assumptions will be, we need to check the sample size is large enough for both. So N1 P1 hat, N1 Q1 hat, N2 P2 hat, and N2 Q2 hat all should be greater than equal to 4. Okay, so here's an example for comparing the two population proportions. To evaluate the effectiveness of carpool lanes toll booth personnel in one city monitored 2,000 randomly selected cars prior to establishing carpool-only lanes and 1,500 cars after the carpool-only lanes were established. The results of the study are shown in the table, where Y1 and Y2 represent the number of cars with 2 or more passengers in the before and after samples, respectively. Okay, so here is what we have. Do the data indicate that the fraction of cars with carpool riders has increased over this period? Okay, so we have the two samples, before carpool lanes and after carpool lanes. N1 is 2,000. Number of successes, 652 out of 2,000 people are carpool riders before the carpool lanes. After is 576 out of 1,500. Okay, so N2 is 1,500. Number of successes is 576. So based on this information, let's conduct the test. So this is the test that we're trying to conduct. We're trying to see that the proportion of carpool riders has increased after the carpool lanes were established. So P1 minus P2 less than 0 is what we are trying to prove. So that before the carpool lanes, it was less. Okay, so we'll start by finding P1 hat and P2 hat. So 652 out of 2,000, 0.326, and 576 out of 500, 1,500 is 0.384. Our test statistic will be based on this pool value or combined value for the proportion. So our P1 hat minus P2 hat minus 0, our D0 is 0. And then for sigma P1 hat minus P2 hat, we will use P hat, which is Y1 plus Y2 divided by N1 plus N2. So 0.351. Plug in all the information. P1 hat, P2 hat. This is P hat, Q hat, 1 over N1 plus 1 over N2. So it gives us negative 3.56. Okay, so negative 3.56, the p-value will be probability of z less than negative 3.56. And if you see the table, the value is very small. It's not on the table. So we can say that the probability is really small, or the p-value is approximately 0. At that point, we can reject the null hypothesis, and we do have sufficient evidence in this case that the proportion of cars with carpool riders has increased after establishing the carpool lanes. All right, so this was conducting hypothesis tests for proportions and difference of proportions. The proportions is when you have just one population, difference will be when you are trying to compare two populations. All right, that's all for today. Thanks for watching.